And thanks for joining me. This is the Adobe Fikemba theory. And in the previous video, part 3, we looked at the measurement of length, the instruments that are used in measuring length, and we looked at their smallest division of graduation. Now, in this video, we are going to be learning how to take reading using this instrument. We're going to be using diagrams to represent that. In my practical class, I will teach you how to do it practical wise. But now in the theory class now, which most questions, when they will ask you questions, they come in this diagram form. So we're going to start with the meter rule. But this one is not usually, they don't ask question from the meter rule axis. But I just want to explain to make you understand. When I explain, I talked about the smallest division of graduation of the meter rule, the vernier caliper, and the micrometer screw gauge. Now let's go. Now look at this now. If you look at the meter rule, okay, you will see that the meter rule starts from 0. This meter rule I drew on the board is from 0 to 10 centimeter. And I told you that the smallest division of graduation of the meter rule is what? 1 millimeter or 0.1 centimeter. So let me explain now. This meter is in centimeter. The implication is that from the differences between each graduations, the differences will be 0.1. So this is 0. The next one is what? 0.1. The next one is 0.2, 0.3. So let me now explain what I'm trying to break down for you to let you know why we say the smallest division of the meter rule, the smallest division of graduation is 0.1. The distance between 0.1 and 0.2 is what? 0.2 minus 0.1 is 0.1. Distance between 0.2 to 0.3 is what? 0.1. So you can now see that as the graduation increases, even as the number is moving like that, the simplest, the smallest differences between these graduations or division will be 0.1. Do you understand it now? So if you place any of your material here to measure, let's say you want to measure the length of this book now, for example. Let's say you want to measure. And now from the 0 mark, you begin to look at where this point terminates, okay, on the meter rule. You know, when I was telling you something about measurement, I told you that when you are dealing with measurements, you are also dealing with comparison with a thing that is already calibrated with a known reference with the other one that is not known. This is not known. This meter is already calibrated with a known reference, meaning it has a defined number to tell us what this one looks like. We don't even know what it is. So we are comparing this with this. This is standard. This is known. So if you measure this from here, let's look at from 0. This is 2, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So this length of this book is what? 2.90 centimeter or 2.9 centimeter. Okay? 2.9 centimeter. So the length of this book is what? 2.9 centimeter from the meter rule. I hope you understand what I mean by the smallest division of graduation of the meter rule is 0.1. So I'm just trying to apply it theoretically with the diagram. Now let's move to the vernier caliper. The smallest division of graduation of the vernier caliper is what? 0.1 millimeter or 0.01 centimeter. The smallest division, are you with me? The smallest division of the vernier caliper is 0.01 centimeter or 0.1 millimeter. Now the implication is that from this point here, I hope you can see, from this point here to this point, since the question is in centimeter, they are all in centimeter, it then means that from here to here, the differences will be 0.01 centimeter. So let's just assume that this one is 0.01 centimeter. What would this one be? 0.02 centimeter. I don't know whether you understand what I'm trying to say. Okay. So now, if you look at it now, in this question here, from this question, they gave us what's it called? That from this place we have 2 centimeter, 3 centimeter, and 4 centimeter. Therefore, since this vernier caliper is touching this place, that's the vernier scale. Before I move on, I want to explain something to you. The vernier caliper has 2 scales. This one is called the main scale. Okay? Main scale. While this other one down is called the vernier scale. The vernier scale. Now, if you look at the main scale, you will see you will see that the main scale is calibrated this way. Is what's it called? We have 2 centimeter, 3 centimeter, 4 centimeter, as the case may be, depending. Now, what you'll be looking at is that whatever you get from the main scale, you will add it to what you have on the vernier scale. Now, let's calculate now. And I told you the smallest division of graduation is what? 0.01 centimeter. So now, let's look at this now. From the main scale, what can we count here? If this is 2 centimeter, can you see? If this is 2 centimeter, what will this place be? If this is 2 centimeter, it means this one will be what? 1.90 centimeter. 1.90. Look at it now. Because this is 2. This must be 1.9 to give you 2. 1.80, 1.7, 1.6. Can you see it now? So you'll be looking at number 1, where this, what's it called? This vernier scale touches on the main scale first. Where this vernier scale touches on the main scale first to give you the main scale reading. So let's take this now. We'll come here and write for the main scale. Main scale, what do we have? We have 1.90 centimeter. Do you agree with me? Because it's in centimeter, so you can see 1.0190. You see it now. So we are following this thing. Now let's look at the vernier scale. The vernier scale, you will now look at in the scale which of this graduation, this division of graduation, that coincides with the what? With the main scale. So let's go. Does this touch any line here on the main scale? No. What of this one? No. This, no. This, no. They are just falling in between. Oh, look at this one. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So the 8th division of graduation coincides with this one. It's touching across this. So therefore, what would that be? What would that be? So this will be what? 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08. So you come with the vernier scale. Vernier scale will be equals to 0.08. Do you see it now? Centimeter. Because it's a centimeter. We told the smallest division is 0.01 centimeter. So let's go. What do we do? 0 plus 8. 8. 9 plus 0, 9. 0.1 plus 0, 1. Your answer is 1.98 centimeter. That's the reading on this vernier scale. Do you understand it now? Now let's come to the micrometer screw gauge. The micrometer screw gauge also have 2 scales. But before I tell you about the micrometer screw gauge, I'd like you to know that the smallest division of the micrometer screw gauge is what? The smallest division of the micrometer screw gauge is 0.01 millimeter. Okay? Or 0.001 centimeter. That is the smallest division of what? Graduation of the micrometer screw gauge. The smallest division of the micrometer screw gauge is what? 0.01 millimeter or 0.001 centimeter. This question is in what? Millimeter. So it's in millimeter. So what do we have here? We have 0. This one here will be 0.5. Are you with me? Now this scale, this one here is called main scale. Before I take the reading, main scale. Why this one here is called the micrometer screw gauge scale. Okay? Now look at this now. Pay attention. We say the smallest division of graduation is what? 0.01. And this is in millimeter. We want to take reading now. So the implication is that you will be looking at the numbers. Look at when you saw this one 0.01 centimeter. You could see 90, this one number here. You could see 0.08, 08, 08, 0. You could see that it tallies with that number. If it's in millimeter, I will have similar number, similar decimal place number. Just like you have this number here, this and this. Now, in the micrometer screw gauge, the main scale, this is 0. This is 0.5. Are you with me? This is 1. This is 1.5. Are you with me? So what would that be? 1.50 millimeter, which coincides with this. It will be 0.01 times 1.5. I don't know that you understand what I'm saying now. So which is what? 1.50 millimeter. Now you will now come now and look at the micrometer screw gauge. We will now look at in this main scale, this line, where does it coincide? What does it touch? I can see it's touching 35. So this is 35 is cutting across. That's where this main scale is touching this other micrometer screw gauge scale. So you now come and say, since this is 35, to follow this line to be what? 0.35 millimeter. Do you see it now? Are you with me? So what do you have? Let's go. This will now be 0.35 millimeter. So if you are going to add it, this is what you are going to get. 5, 8, 1.85 millimeter. So if you look at the decimal place number, see, with this, and look at this. Okay, so with this, you've been able to know how to take reading from the meter rule, the micrometer screw gauge, and from the vernier caliper. So just know this, that you have for the meter rule. For the meter rule, you measure the length. The smallest division is 1 millimeter or 0.1 centimeter. For the vernier caliper, 0.1 millimeter or 0.01 centimeter. And then from the micrometer screw gauge, you have the smallest division of 0.01 millimeter or 0.001 centimeter. And then when you're taking your reading, you add the main scale to the vernier scale, or you add the main scale from the micrometer screw gauge scale to give you your final answer. Represent whatever unit you see the scale in. If it's in centimeter, you follow suit. If it's in millimeter, you follow suit. Thank you. The video might be a little long, but this will help you to understand better. And then, now, next video, we are going to be looking at other measurement of other quantity. Thank you. I'd like you to share, subscribe, and ask questions on the comment section.